Today we're going to be talking about trigonometric substitution. So this is going to be part 1 of a 3-part series. So today we're going to be talking about sine substitution, and other days we're going to talk about tangent substitution and secant substitution. Okay. So let's say we have an integral like 1 over the square root of a squared plus x squared dx. So we have this integral right here. We can't use substitution because there's a 1 up here, so it's just an x, perfectly fine. But we can't use that. We can't use integration by parts, so we're going to have to use trigonometric substitution. So what trigonometric substitution is used for is if you have a quadratic inside a square root. And in this case, you have a square root of a squared plus x squared. That will equal a sine theta. And for tangent and secant, they're different ones, but we're going, like I said in the beginning, we're going to be focusing on sine this video. Okay, so let's get on to an example. Say we have the integral of x cubed divided by the square root of 16 minus plus x squared dx. Okay, so we can, well, the 16 is not into the a squared form, but this 16 can be written as 4 squared, so we can write this as x cubed divided by the square root of 4 squared plus x squared dx. So we now have it into our format: a squared plus x squared equals a sine theta. So right here is a. So in this case, x is going to equal. So a is 4. So 4 sine theta. Well, we still have dx right here. So we're going to have to take the derivative of 4 sine theta, which is 4 cosine theta d theta. This d theta is going to be very important. Just keep that in mind. Okay. So let's plug in x and dx. So wherever you see x, you're going to plug in 4 sine theta. Wherever you see dx, you're going to plug in 4 cosine theta d theta. So x cubed, so it'll be 4 sine theta cubed. And then I'm going to bring the 4 cosine theta up to the top, just to make it a little bit easier. 4 cosine theta divided by square root of 16 plus x squared is 4 sine theta squared, and then d theta. Okay, so now what we can do is simplify this expression. So we can bring the cubed into this, the 4 sine theta, and the square into the 4 sine theta. So give us with the integral of 4 cubed sine theta times 4 cosine theta divided by the square root of 16 plus 16 sine squared theta d theta. Okay, so what we can notice here is we have 16, a constant, plus that same constant. So what we can do is we can factor out a 16. So give us 4 cubed sine theta, 4 cosine theta. And over here, if we factor out 16, it'll give us sine squared theta plus 1 d theta. Alright, so sine squared theta plus 1, that is cosine squared theta. Alright? So that, in this square root, it'll give us 16 times cosine squared theta. But we take the square root, it'll give us 4 cosine theta. So just the integral of 4 third sine theta, sine cubed theta, and then 4 cosine theta divided by 4 cosine theta. So we can know, well, we notice that these four cosine thetas cancel out. And it will give us we're going to bring 4/3 out, the integral of sine cubed theta d theta. Okay, so we take the integral of sine cubed theta. This one can be a little tricky, but if we have a trigonometric function raised to an odd power, what we can do is we can expand it out into an even and an odd power. So in this case, it can be sine squared theta times sine theta d theta. Okay, so we can't do anything necessarily now, but we can. The sine theta is the same as 1 minus cosine squared theta. So we can erase this right here. So this is 1 minus cosine squared theta times sine theta d theta. Alright? So now we can do a u substitution here. Since if we substitute u for cosine, sine will cancel out. So u sub, so u is equal to cosine theta, and du will equal negative sine theta d theta, but we have to divide it by -1 by both sides, will give us negative du is equal to sine theta. So all this means we'll bring this negative to the front. So give us -4 cubed integral of 1 minus u squared du, because the sine cancels out. So we take the integral of this, which will give us -4/3 of u minus u cubed divided by 3 plus c. But now we have to plug back our u, which will give us -4/3 or 4/3 cosine theta minus cosine theta cubed divided by 3 plus c. Okay, you may think we're done, but in original example, it was with respect to x, so we have to bring it to the x world. But in cosine theta, what we can do is draw a triangle, a right triangle, and with a right triangle we can find what cosine theta is, sine theta, and tangent theta is. So I'm going to draw a triangle. So as x equals 4 sine theta. So we want to get what is sine theta? So we're going to divide by 4. So x divided by 4 is equal to sine theta. So we know what sine is. So sine is opposite over hypotenuse. So it's the opposite side over the hypotenuse. And then now we can just do Pythagorean theorem to get this final side. So I'm going to erase some of this right here. It'll give us x squared plus b squared is equal to 16. Subtract x squared will give us b, and then take the square root. It will give us 16 minus x squared is equal to, and b is equal to the square root of 16 minus x squared. So this is going to be that side. But we found all our parts of our triangle, so now we need to find what cosine theta is. So cosine theta is the adjacent over the hypotenuse. And the square root of 16 minus x squared, that's the adjacent side. The hypotenuse is 4. So for cosine theta, for all cosine thetas in our equation, cosine theta is equal to the square root of 16 minus x squared divided by 4. Okay, we're almost done. So where all the cosine thetas are, we're going to plug in square root of 16 minus x squared divided by 4. So -4 to the 3 of square root of 16 minus x squared divided by 4 minus square root of 16 minus x squared cubed divided by 3 plus c. And there it is. As you may have noticed, these problems take forever, but you have your answer. Final answer is the only way to solve if you have an integral with a quadratic instead of square root. Hope this video helped out, and thank you for watching.